Hi, my name is Colin Melia. I'm the founder and principal architect at Ace of Clouds. I'm actually speaking to you today in my role as a Microsoft Regional Director, one of about 100 in the world, and also as an MVP awardee with expertise in the XAML area. You can follow me on Twitter at Colonizer, or you can see my blog at colonizer.com. Today I'm really talking to those people in the audience who want to know how to use XAML and .NET to develop for Windows 8 or for Windows Store apps. If you're an existing .NET developer, this presentation is already also for you. If you're a Silverlight or WPF developer, this presentation is again for you. We'll talk about, in this presentation, the basic controls that are used, the kind of styling that's used, some of the things you need to know about layout and scaling when looking at a Windows Store app. There are a few things to a Windows Store app that you need to consider. Certainly you've seen a lot of graphics and styling out in the media and on the web about Windows Store apps. These are some of the elements you need to think about. There are Microsoft Design Style guides that you can use to look at these apps. They're previously known as Metro Style, or now it's the Microsoft Design Language, that you can look up and see about some of the kind of positioning and spacing and styling of controls and the overall app that you're building. You've heard the word fast and fluid, that refers to the responsiveness. Some of that comes from things like async programming. While I'm not dealing with this, you can certainly find other resources or presentations that deal with async programming to provide a fast and fluid response to users. These are all possible with XAML and .NET, and equally using HTML JavaScript as well. Now, there's also snapping and scaling capabilities. You want to be able to handle those correctly. In fact, you must handle those correctly to pass certification for Windows Store app. You also want to use the right contracts. There are share contracts, settings contracts, and the search contracts for the three basic contracts that most people consider for their Windows Store app. You have to at least support the settings contract in order to have your application go through the store certification process. You want to think about tiling. Again, while this presentation is not about tiling, you certainly want to consider live tiles, updating live tiles, or even push notifications to give the user the impression that your application is information rich and constantly running and providing useful information and value to the end user. Again, connecting tiles and background processes, you can make your application feel alive and connected to data on the internet. The whole framework, the WinRT framework, is geared to allow you to make asynchronous calls, get data from the device, get data from the web, and present that to the user in a great way. You can also have your settings roam through the cloud, so if somebody uses their Microsoft account, formerly a Live ID, to log in, you can have the settings roam between apps. These are kind of traits of a great app. And you really want to, again, design the design principles. This particular presentation is more about this design and the controls and how you get started using XAML, or how you can use the controls and the look and feel and the projects using XAML and .NET. So as the case with WinForms and Silverlight and WPF, there are some built-in controls that you already have at your disposal. So we're going to look at some of those. These ones already implement the Microsoft Design Language, and so you don't really have to do any work on them to make them look the way they should to be great in your application. They're also designed for use with touch, mouse, and a keyboard. Windows 8 is certainly designed for use on a slate where there's no keyboard and no mouse, and touch is an option. So all the core controls work in all three scenarios. If you were to build your own control, you'd want to make sure that it complies with touch, mouse, keyboard, whether it's only one of those or some combination of those three. Also, the controls that you can use are available both in XAML and if you build with HTML and JavaScript. So they're native in the sense that they're built in there. You don't have to go build them. You can build your own, but there's a core set already there available for you. So in XAML, you can declare things, or you can do things imperatively in code. If you did WinForm programming, you're probably used to the idea that you have some sort of named control and there's an event, and you can wire up some sort of event handler or some sort of piece of code that will run when something needs to happen. So in this case, there's our visual representation of our toggle switch as it will look in our application. And here's our the XAML, or the way of declaring this just in text. We'll see this more in action when we get to a demo. And here's the way of doing the same kind of thing, kind of in code. They're not quite the same example. For example, I could actually, this declares my code, this declares my control, and this sets up an event handler. I could also just declare an event handler in text on the end here as well. So if you're not quite ready to go the full leap to declarations or declarative code, you can just go with imperative code. Here's the kind of widgets and things you expect to see. You'll notice that there are a few have a star here for like the date picker and the time picker, which are not kind of built-in controls, but there are control libraries available, both free ones and well-known branded sets of controls you can use to build out your application with XAML and .NET. The usual characters are all kind of here for us to look at. Also, you can style those controls. If you don't like the look and feel, you can certainly change the appearance to suit your own needs, or the style of the application, or the brand of the application that you're building. So I'm going to show you the everyday widgets that you might encounter. So let's go and have a look at the standard controls. Here's a project. Here we have a solution with multiple projects. Each project is a Windows Store app, effectively. Some of the core pieces of our application are the app.xaml, app.cs. This is like the main handler in your C++ code or C#. It's the way that the program kicks up, decides which page it's going to load, or in the case, it's similar to a Windows form, which one it's going to load. And in this particular case, we're going to load up our main page, and that's going to host a series of user controls. We think of those as subpages. So let's just start the application up so you can see what's going on. So here's our example. Let's go and look at the buttons. Here's your typical kind of button. You can click ahead and you see something happens. Here's some text happens in reaction. You can put some, you can change the text that's inside the button. You can have a toggle button. You can change the way the style. So we've got nope and sure. So we can change this to no way. And you'll also see that there's a kind of like a binding dynamically happening here, where we've changed things and things update. So the way that the user interface works with XAML applications is not, for example, with an hwind for every single look control. It's actually using DirectX underneath to render things directly. So it's a much more kind of higher frame rate, or more like WPF in a sense, but it's part of the platform now. So we've got other controls. We can check boxes. We can link to the fact that it's checked and determine it's checked. We have a hyperlink button. We have a radio button that's checked. We can customize the content. So you can see a button as it stands is quite flexible, the kind of things we can have. A few of the controls that you've probably seen already in applications running with Windows 8 is the progress ring. Of course, you can have a larger version. You often see this when the store app is loading up or other apps are loading up, and we can turn it on programmatically, or in this binding case. The progress bar is another one that you want to use in your application to show the user that something is happening. You can change between determinate or not, and I can put a value in. So if we know what's going on, it's very subtle here, and you may not see it, but if I put in a value of 100, it actually animates up. So all that kind of animation is built into the control already. I could also have a pause state where it dims, and an error state where there's nothing to show because something has gone wrong. Other examples, we can take a control and we can show a style. So here we have a regular button that we might click, and here we have a version that's been styled by replacing the content with an image. So it's not very responsive, and we expect something better from control, especially with a mouse movement. So there's the idea of a visual state manager, where we have a button and we can declare states. We can declare that this particular button behaves in a certain way when we move over the control and when we click on it. And we simply just declare what we want the button to look like in those various different states. So I'm just going to take you under the hood now to show you what that looks like. So we'll stop running for a second, and we'll go into, I think, scenario 6. And let's have a look at the button. Now, so here you see that there's a normal state, an over, a pressed, and a disabled state for this button. In each case, we're actually just making a few changes. Now, what you may not have realized is that the arrow that you were seeing was actually, a drawing, so we can just apply color changes to the drawing. just to dive in a bit more to the XAML that's going on here, so the extensible application markup language, what we have is we have a grid. We've declared a grid. We have a stack panel inside there, which is just for stacking controls, a text block, which is the equivalent of a label, and a button. So again, like a button you might have similar to WinForms or in WPF or in Silverlight. So here's our button, and we've got some content in it, and there's something we can do. In here we have another version of the button which has a different style, and all that's happening is we've got this Visual State Manager associated with it for the refresh button style. Again, if we go down here, you'll see it's the refresh button style. So we've said we want to use this style, and that style means we've set various things, including how the control is built up from scratch, and this Visual State Manager, that when we set the appropriate state, it'll actually do something else. Now this says it's an animation. It may be instantaneous. In this case, it is instantaneous because the duration is 0. But what we can do is we can very quickly and declaratively kind of build up our interface and have states for things, and a button is the prime example of when you'd use a state. So there were some of the various widgets that you might expect to see, the usual type of controls. Let's move along and see what else we've got. Well, obviously we have text boxes. We have the single line text box, multi-line text box, the password text box, and the rich text box. In the case of the single line text box, one of the new things you'll see for controls on Windows Store apps is this clear button. So you can click on the clear button and it'll clear the contents. You'll have this reveal button, so you type in a password, it's kind of starred out or dotted out in this case. And if you click on the reveal button, you're actually going to see temporarily, while you're holding the button down or touching the screen, you're going to see what the contents of that password is. The usual suspects instead of the multi-line text box as well. Now selection is interesting, and I'll show you this in the demo, but selection works with mouse and keyboard, as you'd expect. It also works with touch. And when we deal with touch, there's some extra things we have to do to make selection more palatable or even manipulable, if that's a word, to make it so that if you have a slate device, you can still get on with the job at hand. Another big feature is that spell checking is incorporated. So if you enable spell checking, it's there for free. You don't have to build a whole lot of spell checking code or a dictionary or something else behind it to get it to do what you want it to do. Also, of course, there's the on-screen keyboard. The on-screen keyboard pops up, when you click on something and there's no keyboard active at the time. If you click on text entry, you'll get the pop-up keyboard. There are a number of different keyboards, and in fact, the keyboard that shows up may be contextual based on the text box. You can declare information against the text box that will help the operating system bring up a keyboard that's most suitable for what you want to do. It might be a telephone number in this case, in which case you don't want the characters from the alphabet, you just want the numerical ones instead. So let's show you the text editing. Let's close this down and go into the text editing one. These are all samples that I'm showing you that you can download and see what's going on under the hood. So don't worry if I'm flying by these at some speed. You can go and take a look and see what's going on. So here's a standard thing you'd expect to see. Here's a text block, usually known as a label in Windows Forms terminology. You can select with your mouse. That's what I'm doing right now. You can do the same thing in the text box, and I can kind of edit away in the text box. Now the other thing is I can use touch. So if I were to touch the text block or the label there, you can see if I click on a word, it highlights the word. That kind of, I'll just show you there that you can see this gray circle. I have an extra feature turned on in Windows that allows you to see where I'm touching. So if I go and click on a word, you can see the word highlights. I can take one of these little dangly ball things here, and I can drag around. And you can see where I'm dragging with the gray circle there, and select the text I want. Once I've done that, I can press and hold, and I can copy. If I were to do the same thing with the text box, we'll have a different experience. Now you can see the right thing has kind of happened. It's come to become visible, and I can do the same thing. I can go ahead there. I can select, drag and select, but I can then type away. I like to have this particular keyboard selected. It's good for thumb typing at the corners of the screen. But of course, there are different keyboards, a regular keyboard and smaller keyboard available, including writing if you have a digitizer as well. So if I Go back on here, select something over here, the keyboard disappears and we're back to where we were. Other few things, for example, I can programmatically see what's been selected. I also have text prediction with the keyboard, with the on-screen keyboard. So let's say I select there with my mouse, nothing happens, I could type away. Let's say I select there with my finger, then you can see I'm ready to type. And if I start typing away on this on-screen keyboard here, let's see what happens. See if I can get any useful information. Let's try again. If I type something, meaningful, then I'll get some hints as to what I can type next. Let's see if I can get that to work. So I haven't got any text prediction there. Let's follow the actual example and do what it says and type in the word vac, see what happens here. So V-A-C. Nope, it's not going to work. So essentially, but what you can get is kind of text prediction and words that come on and help you to do what you're supposed to do. It's off by default when you enable it. So it seems to be not enabled in this demo for some reason. Also, there's the standard password box where I can type away there. There's the clear we saw before. And there's the password box where I can type away, and if I hold down, you can see temporarily what I was doing. There are also a few other interesting things we can do. We can have linked text containers where the text can flow from one to the other. So if I bring the font size all the way down, you can see that it's actually spread across multiple boxes there. And there's some other line height manipulation you can do as well. So there's a lot of rich stuff you can do with text for the application that you're building. So how about actually doing all the commanding services? So we've talked about controls that might build a single page or be used on multiple pages. What if you want to kind of navigate or move around or kind of engage the user in some sort of specific action or command? So there are a few things you can do here. There's the app bar, which is available throughout the operating system in different types of applications. And there's contextual menus. There are tooltips. Tooltips take an interesting kind of back seat in this world because with touch, there's no mouse hovering if you have no mouse attached. So you need to consider, for a tooltip, does it make sense? It might be if you press and hold, the user learns something else and you see a tooltip, or it might be the tooltip hovers around near to where the user is touching so that they can see information. So again, tooltip maybe not the right thing that you want. There are also dialog boxes for the usual kind of messages. There are also a couple of other ones here that are mentioned here, the flyout, which might happen when you click on one of these commands up here. For example, you might get a palette of colors in a flyout. And the settings pane. The settings pane isn't available as a specific control, but you can build it with controls. That's why it's not, it has the asterisks there as well. So let me show you the app bar in action. Let's take a look at that. So the app bar is reasonably straightforward. Let's just start it off. Again, this is just a simple sample. Oh, sorry, wrong one. Let's do that again. So here we have the app bar sample. And you see there's nothing going on right now. If I were to engage the app bar, you'll see the app bar appear. Now there are three ways to do this. One is to right click the mouse and you see the app bar appears. One is to actually swipe up or down on a touch screen. So I'm swiping up and down on my touch screen and I see the same thing. There can actually be two app bars, by the way, one at the top and one at the bottom. The same motion or gesture or action brings up both of them at the same time. Or I can use Window key plus Z, same kind of thing. I can toggle them on and off here. So clicking these doesn't actually do anything, but you can have click handlers for these just like you would have for a button. Same kind of thing. So on and off. Now there's also a thing called light dismiss here. If I click on somewhere else, it goes away. There's the option to make it sticky. So if I say it's sticky and I bring it up, right click for example, I can click around on here and it's going to stay. That's kind of, great. That's in some circumstances, because that might be have different options, and clicking the options, I want to select different things, or kind of a user experience that goes around between those two things. So that's sticky is useful in that particular scenario. There also might be an example where you want to have something on all pages and only some things on 1 or 2 pages. So in this case, I have a back button that appears, and when I go to page 2, let's go to page 2, I have a back button again, but I also have something that's more local or scoped to this page. So it's possible to do that where you have some global elements and some contextual elements. In fact, that's a recommended practice, that you have kind of like consistent buttons, because if the user is holding the tablet and they expect things to be in the same place whenever they swipe up from the bottom, and if things start moving around at least on one side, it's going to be quite confusing for the user. At least they can expect consistency on one side and catch the contextual stuff on the other side. The app bar is very straightforward to get into place. Let's just take a look at that. It's in our main page. So here's our main page. Let's make that a little bit bigger. So we're just looking for app bar. So app bar is just again defined in XAML, just like everything else. So by declaring app bar on this page, when we go to this page, the app bar will be available. You can see it just has buttons in it. It can actually have any XAML controls in it, so you can build up an app bar that's kind of crazy if you really want to, but you should try and stay in line with the guidelines and make it consistent with the experience from other applications. But you can have lists of things in there. For example, it might be even dynamic list of things. So here you have, same kind of thing, a button with a style, and it has a tag that's used when it's clicked, and you can have a click event handle if you want to as well. So there's your app bar easily added onto that page. So presenting data. Obviously, data is kind of quite key to your application in many ways. It might be graphical, it might be obvious lists of things, it might be something that you manually draw or express in some way. There are 3 main ways that you might show your data in the application that WinRT helps you with. The platform underneath helps you with. There are 3 controls that are provided that will help you. There's the list view, the grid view, and the flip view. You've probably seen lots and lots of demo applications that have the grid view in them. It's a standard kind of view with some sort of dynamic number of tiles. You can think of the start screen as very much like that. The store app has a same kind of experience. You also have the flip view. If you go into the store and you go into the page for a specific app that you might be interested in buying, you'll see screenshots. And those screenshots use the flip view to allow you to go between different screenshots, and you'll see the kind of signature left and right arrows to flip through those things. The grid view, as I say, was kind of a main page type of classic thing, and the list view is something that you might see in other pages, or maybe when you've snapped the application to the right hand side of the screen, and we'll talk a bit more about that in a little while. So they're the classic ones. You're not locked into these, you can do something else, but certainly there's controls there and examples there that help you get started with these particular types of controls. You've also seen probably grouping with the grid view. This is a very simple example of small lists, but these might be multiple icons. So for example, on the start screen, you might have, start screen, this is one group and it has lots of things in it. Here it's just a simple list. You might have single and multi-select. I'll show you how those things work as well. You can do that again with the mouse and the keyboard and with touch. And there are also some built-in animations. Animation is kind of pretty key to a nice user experience, a fluid user experience, whereby, for example, when controls appear, they slide or glide into view. It's very subtle and it's only over maybe a quarter of a second, but it gives a nice feel to the application. Semantic zoom is also a key feature that's been kind of elevated as a design principle for applications that have lots of information. In this particular example, what's happening here is there are a number of appointments, and there's a lot of detail about each one, and you can see how we're scrolling off the screen here in terms of a large number of appointments. If I can zoom out and have like a 10,000 foot view of that, then what I prefer to see is, well, I can see I have appointments at these times. I don't know what the detail is, but it gives me an idea of my day and the number of appointments I have, and this day is obviously less, this day is more. And if I can then click on one of these and zoom back into the relevant area, I can quickly move around. If I had 100 appointments, I don't want to be scrolling around to find the one I want. I want to be able to zoom out, go to where I want to be, and zoom back in again. The same thing happens with the start screen. Semantic zoom is there, and you can use the semantic zoom control to achieve the same results, where you give it a kind of a zoomed out view and a zoomed in view. So using the grid view is fairly straightforward. You just need a few elements to go with it. So you have a grid view, kind of looks like this. It might be the tiles, it might just be lists like this. To get started, you need some data, and you just set the item source property of the control to the data you have. It just needs to support IEnumerable, which is a fairly well-known kind of premise now in .NET with LINQ especially, even whether you're using WPF or XAML or not. If you can just set the item source to something that follows IEnumerable, you can bring stuff in. Grid view is special because it also has a notion of grouping. List view and list control and items control just do standard lists, but grid view can understand grouping as well. And how to group objects. So you have it set an item source. You set an item template. So an item template is just a piece of XAML. It's basically saying, if I want one of these small little pieces here, what would I have to do? What do I want that each one of those items to look like? It's a stamp or a building block for how you want those things to appear. So you set an item template for and that's used for each and every one. It's actually also possible to dynamically have different templates depending on the type of thing. This is like a homogeneous list of items, but it's possible to have a heterogeneous list of items where you have different things and each can have a different template. Or you might have a list whereby you have a certain type of things in one group and a different type of things in another group. You also need an items panel, and the items panel is essentially saying, how do I want to lay these things out? The standard behavior in most of the project templates is to have a wrap panel. So when you see those tiles on the start screen, for example here, there's some wrapping going on, and I fill in here, and then another column. You can choose to fill in by column or to fill in by row. On the start screen, it makes more sense to do it this way around. So my items panel could be something else, like it just could be a virtualized list or a long list or some other layout. I can even create my own custom panel to lay things out the way I want them to be laid out. So I'm not stuck with just having the ones that are there. I can create a radial panel, so I can have things laid out in a circle and make things fit that way. I also can specify the style for the item container. The item container style is actually important because it does things like putting borders around and showing you that you've checked an item. So that style can be quite key if you want to change the underlying colors and that kind of thing. So the item container style is like the border around the whole thing. So this is what the XAML might look like. Again, it's possible to do this whole thing in code, but this is so much easier just to declare what you want. So we want a data template for an individual item. We're going to say it's a stack panel, an image, and a piece of text like a label. Here's the actual grid, and here's our which contains a grid view. So this is just a grid. This is a throwaway grid container for now. Here's our grid view, and we're saying that the item template is going to be storefront tile template, which is up here, storefront tile template. So every time there's an item in that grid view, even if it's in a group, we're going to go for the single template. We're going to use this template for every single one, and we're going to bind to some data. So that data should have an image property, and that will be displayed to us for each. Hopefully, if every item has an image, then we'll get an image for every single one. Now, there's also an item container style, storefront tile style, which has been set here. So this is going to show you. This is going to determine what's going to happen for each item in terms of various styling properties. We could also go all out and completely control the layout as well. And then there's just another extra specific style locally defined there for a border brush as well. So let's go into a demo about how you actually do this kind of thing. Let's get rid of our other stuff. And list view example. So here's a list view. This is going to show us list views and grid views. This particular one is a grid view. You can see that it's wrapping along, and there's a scroll bar involved, and we have items here. And this is kind of what we were looking at. In fact, this is the code. The code we just saw is from here, where we have an item, and we have a piece of text. So we can make it respond to click events. By the way, if you see there, just as I change, you can see the subtle animation that's built in. And actually, if we add and remove items, there are animations that are built in for that kind of thing as well. So we can respond to click events. I can click the succulent strawberry, and we can see that it's clicked right there. Or we can have a list view. We also talked about being a standard list view. Think of this like being a list box with obviously the XAML power of styling here involved. And there we go. So that's pretty straightforward. Let's go and have a look at how that runs underneath. So in our list view, we have a few scenarios. Let's make sure we pick the right one. So for example, scenario 2 was with the click. So let's open the XAML here. Let's maximize to see the XAML. And we have a stack panel. No, that's not the one we want. That's the input box. We want the output box. There we go. So here's our grid view. Again, we've just got an item. This is what we want all of them to look like. Now, if you remember, we had the kind of précis version of this before. So let's go hunting for this. Mostly our styles that can be defined in the same page, or they can be defined in a containing page if there's a user control, or it's going to be in app.xaml. So let's go over here to app.xaml. Let's make this a bit bigger so you can see what's going on. And here's app.xaml. We're going to search for the thing we just had. There we go. So there's our style right there. And we're defining our image and a stack panel. And this stack panel is horizontal, which explains why we see the picture and then we see the text from left to right. So there's that one particular style we were looking for. The container style, again, is defined in the same way. So let's go and hunt that one down. And here's the example. We could change this, and you'd see an immediate change when we run the application in the styling. And there's also the items panel. So items panel is also defined as a style. Let's go and find that. And there's items panel, and you'll see that it's actually a wrap grid that's used, which is kind of the same as the start screen. So the wrap grid gives you that wrapping behavior by column. We can change this to a list or some other fancy control we want to declare ourselves. Now, these could have all been declared in line, but it's nice if they're all consistently in a central style repository effectively. And you can see how that works. We've got let's have a look also at the data. So we can click on an item. There's a click handler. Let's just go in here to the code underneath. You'll see that at the beginning we set item source, as we said, one of those things you have to set, and there's also an item handler there to tell us that something else is happening. So that's quite straightforward. Let's close that down. So, talk a little bit about layouts and views and why those are important to a Windows Store application. So these are the kind of things you might encounter with new Windows 8 devices. Obviously, a variety of screen sizes. This could be your big screen TV, your desktop all in one, your regular desktop, your tablet, and who knows how small this might go in the future. So there are definitely different screen sizes, physical screen sizes. Now, the user's also able to do snap an application to the side. I can actually show you that if I snap this application to the side, you can see I get a certain behavior going on here. Snap to that particular side. I can snap to the other side. I can bring something else in. I can drag with my finger and make this be the rest of the whole size. Let's just snap again to the right. I'm using the keyboard here. You can do this with the mouse or your finger. Let's just take that and do it to here. I don't have another app snapped in right now. I can also have portrait. If I pick up my computer, which I could do precariously, you'll see that we actually get we'll get some orientation changes as well if the app supports it. We also have Obviously, this is PowerPoint, not a WinRT app, so I won't do it right now. We also have pixel density. As you know, devices are getting smaller, but resolutions are increasing. If you take, for example, the Surface Pro device, that's extremely high resolution, 1920 by 1080 in an 11.6 or 10-inch package. So that's extremely high DPI, which means for high quality. There is an issue with that we'll discuss, though, and you need to be able to support that scenario. So you should care because you want to have things look at the right size. You don't want things to be too small. You should care about layout because you have to, in order to pass certification. Your app has to behave reasonably well when people snap your app, snap it, make it the big app and not the snapped app, so fill it and have a snapped app next to it, or when the user orientates the screen. So you have to get that down, and you also have to care about pixel density to some extent as well, although not actually a requirement for passing certification. So with your screen sizes, you want to care about apps being immersive as possible. The minimum app resolution you need to be able to deal with is at 1024 by 768, so you can count on that as a size. If the screen that's being used is that resolution, it does not support snapping to the sides. So the app will only be that big, and the user will never be able to snap a second app next to it. So really, you should actually aim for 1366 by 768, which is the minimum screen resolution a system should have in order for you to be able to have snapping. So when there's no snapping, this is the size your app will actually be. So you can actually make use of that fact if possible, and we're going to talk about how you do that as well. So there are two ways you can deal with the screen size changing. You can take the view that you want to adapt, so if there's more space, you can make use of it. You can also take the view that it's you want a fixed kind of aspect ratio, and you just want that to scale up and down to fit the spaces available, while giving you some sort of border on the top and bottom, or the left and right, depending on the device. There are some examples here that are attempting to show that, for example, we have more screen real estate here, so we have 4 columns. Here we have less, so we only have 3 columns. In this particular case here, we're having different size screens, but you still see the same aspect ratio game board in this particular case. So if we're going to be adaptive, we should try and take advantage of what's available for us to use already. The grid view and the list view are great because, just going back to this example, if I use a grid view and I give it data items and there's more screen real estate, it's going to give me the extra, it's going to use the extra space. So that's a great thing to use. I don't have to worry about so much about whether I have what kind of aspect ratio the screen is. I don't have to worry about if it's snapped or not, because I don't have to worry about if it's filled and there's something snapped next to it, because it's just a little bit less space. Effectively, if I take this and I were to snap another app to the right hand side here, then I've got this much space. So this kind of using the grid view seems to be a sensible option if I'm going to be adaptive in that way. Obviously, if I use a list of any kind, I'm going down the screen in a portrait view, then obviously I'm using lists as good, and scroll bars are good. So you can either scale in size, or you can use a list box, one of those two options. If you also need to consider another thing, which is the wireframe of your app. The standard layout for most Windows Store apps is this idea that there's a wireframe whereby there's the margin on the left-hand side and a margin across the top. And this is just the standard styling. It's not compulsory, but certainly you have this piece of content area, and the top part and the left part may be a fixed size, but this part here is definitely going to change as you snap, unsnap, change to portrait and landscape, or have a different screen resolution or DPI. So you want to use the grid here with star sizing to fill out the space if you can, or you might just put a grid view control in there instead. You can also use a stack panel to fill out space, but ideally you're going to have some blanks at the end. So if these controls are up here, they just nicely go along until they run out of space. But you might need a scroll bar for that if you're going to go past. If there's a possibility it might go past the edge. Here's an example of that kind of like wireframe in place. Here you have two columns. This is an example of kind of like text, not a list. This is text or some of the graphical element. Here it's a nice idea to be able to have two columns. Maybe when it's in portrait orientation, you might decide to have just a single column. So you need to consider that as well. There's the width you have to play with. There's one particular column. Now, if you can choose to go with fixed layout if you want. When you define your grid, you can say what columns you might have, and this is the exact pixel width you're going to go. And you're going to have, for example, this rectangle come up. Now, that's great, but then you're not really using this space very well, and it's just blank space. I mean, if you don't put anything in there, maybe it doesn't matter, but fixed layout isn't particularly a great way to go. It's the same kind of with web design these days. If you're going to have a web design that works well on mobile screens, you need to adapt and not necessarily have a fixed width, unless you're having separate styling based on the browser detection or media queries. So here, fixed width, not so great. Now, star sizing, the idea is that maybe we have some fixed width, as we did in our wireframe. We had a margin on the left, which is 250, but that we had a piece in the middle, which was flexible. So here, the star sizing is the piece in the middle. Our rectangle is in that column, and these two pieces are going to stay fixed. But if the screen size changes, this is going to work out better for us because it's going to fit in nicely and expand. Obviously, it's just a rectangle. It's a simple case, but if you have other controls, you get the idea. So if you do put a control in that column that's now scaling, and by the way, in this case, we've got 2 star and 1 star effectively. So this will always be twice as big as this, and because we're stretching, this button will stretch to fill. Not the greatest aesthetic for a button, but for other controls, it might make sense, like a text box or a text block of some kind. Now, you can also do scale to fit. This idea that you have something and you just want it to always be the same shape, but just kind of the whole thing zoom in or out or scale up and down to fit the space available to you. Here's the kind of thing zoomed in here. In that case, what you're going to do is you're actually going to use a view box. A view box is a control where it locks the aspect ratio. It knows the size of the thing inside of it, and it visually scales the rendering of that thing up and down to make it fit in the space available to it. If you have more width, however, in this case, you wouldn't this wouldn't get bigger. It might center itself and move over a little bit, but certainly if you went from being in a small narrow column when you're snapped to when you're full screen or just filled when there's something snapped next to you, this kind of box, the view box might be a solution you might want to use. You also want to build for snap. Again, you might use a view box. One of the general things that's done is when you snap something that's a grid view, you often change it into a list view to simplify what's available. And here's another example where in portrait view, you have less width. And in fact, what you'll also see is that this margin here gets narrower because otherwise it's a waste. The typical wireframe we have, let's just go back to the wireframe just to show you, is quite large. And you don't want to be wasting, see there's a lot of wireframe here, you don't want to be wasting that when you're in portrait mode, but you still might want a border because it nicely evens things in the display out. So when you add a snap view, like I said, you have a specific width, and it is really a specific width, it's 320 pixels. If you have a grid, you're probably going to turn it into a list view, and it's going to be a very long vertically scrolling list. Normally, the scrolling is from left to right. In this case, it's going to end up being vertical. If you have non-list based items, then you'll probably want to put them into some sort of vertical scrolling appearance of some kind in a single column. For portrait view, you have a bit more width. Like I said, the margin here is going to be smaller, otherwise it's definitely wasted space. If you have some sort of textual layout like a newspaper or comic, you might want to use margins or place things on top and bottom instead of left and right. If it's a grid view, if you're using a grid view, you're sorted because it'll just automatically expand to use the extra rows you have. Again, another great reason why you should use grid view in the first place. So there's a great way to help do some of this stuff. Here you'll see the form factors I've been talking about here. There's the full screen, there's the fill, where something is snapped next to you. There's a case where you're snapped with something next to you, or you're in portrait mode. By the way, you don't really have an option about portrait mode. You can say what you prefer, but the operating system will go, I'm sorry, the user has gone to portrait mode. We're gonna go and render and fill however you've made it work, and it needs to look good. But you can specify a preference in your code, or rather in your XAML, or sorry, in the manifest. So in this case, what you want to really be able to do is use this thing called the Visual State Manager. It's used for buttons, but we can also use it for other things as well. So we can say that the state of the page has changed, and we might want to apply some animations, where an animation is just moving something, even if it's instantaneously. You can always do a fade or a move if you really want to do so. So there's also some helper functions you can use that make things easy for you. I'll actually show you what this kind of function looks like. It's where you'll pass in information about what the display is doing right now, whether it's orientated, and you can actually you return back the name of the view state you'd like to go. So these are the view states that are available. You take the information available from the device in terms of its orientation, what's snapped, what's not snapped, and you map it into one of these view states that you have available to you. It may be that for some of the view states, as we'll see in the example, you don't need to specify a different movement or change of things or control layout. So let's have a look at that specific demo. So here I'm going to show you an app running. So here we go. This is our app running. We're using a grid view, so we're getting the benefit of, everything's nice and it fits nicely and all that kind of good stuff. And the stuff I can select. Now, if I were to do something like, let's just find another app. Let's start the weather app. Where's the weather app? So here's the weather app, and what I'm going to do is I'm going to snap the weather app to one side, and then I'm just going to flip in, I'm going to flip in, and there we go. So I flipped in my app, so I have my app and the weather app. I could, you can see that my app, because it's using a grid view, the grid view just uses whatever space is available, and things are just fine. And if we change things over the other way, let's snap this way, you'll see that something quite different has happened. It's gone, well, really, there's no point having a horizontal scrolling thing there. It doesn't make any sense. And you saw a small animation and things changed into this state where we still have the same semantics. We have groups and items, but it's been put into something that's more usable at the side there. So, consider it being a Twitter feed or something else. And certainly the weather has now expanded to use the space. So what you're seeing is that the view for filled and the view for full screen are kind of really the same view in many cases because you have the same amount of space available. Maybe if it was a game board, maybe not, because you'd have to scale things down. But this is hints that things are good this way. If I'm just going to risk this now, I'm going to tilt my device and we'll see what happens. So if I tilt my device, eventually you'll see this is going to look funny from your point of view, but it's using more rows now. The grid view's done its job. So definitely, even for portrait, it's better. But look at that left-hand margin. There's the left-hand margin regular, and if I flip it and you just tilt your head on your side for a second, you'll see that the margin's slightly different. So we don't want to waste a massive big left margin if we don't need to. So there you go. That's good. So let's see how that's actually being handled underneath. We can get rid of the weather app now. Let's go here and look inside the app. So on our page, scroll down here. So there's the grid. This is the grid view that you see most of the time. It's got a group of stuff in it. It's got a template for what the group looks like. It's got a template right here for what an individual item looks like. We can find that. We can go and find that template inside our app.xaml, and sometimes app.xaml just includes another XAML file, which is in here. So we'll find it under standard styles. You'll probably want to pillage and plunder the standard styles.xaml file for all the good stuff that you want to make your stuff work nicely. So anyway, back to here, we've got our grid view, and you'll also notice we have a list view, but you don't see them both at the same time. So the grid view actually has a name, item grid view, and the list view has a name, item list view. So let's just keep going down the page, and what you'll see here is you'll see a view state, this view state manager, and you'll see we've got full screen landscape, and filled. Now there's nothing in there. These are empty XML because we're using the grid view. When you're full screen in landscape, or when you're filled, which is when something's snapped next to you, the grid view just does a great job. When we go into portrait mode, all that happens is we just move the back button slightly a little. So we change the style of the back button a little bit, and we move the margins a little bit, and that's it. And when we're in snapped, it's a bit more radical. Same kind of some changes with the title and the button, but also we changed the list view to be visible. Let's just zoom that in a little bit for you. The list view to be visible, and we changed the grid view to be collapsed. And then when we flip out that style, this kind of animation set gets disengaged, and we go back to where we were before. So let's just see what's going on also underneath. So this is the grouped item page. There we go here. What you'll see is that this page inherits from layout aware page, which is a bit of code that's available to you right here on my right hand side that you can use, that comes with the kind of standard templates, and it kind of does the magic that you're looking for to help you switch around. Now there's a function here you can override. What's happening is it takes this view state, kind of application view state that's passed in, and you return a string. That string becomes the string that it looks for in terms of snapped or whatever else you're looking for. So you can take in the information that's coming in. You could say, hey, I don't want to do snapped. I don't want to do it like that. I want to call it something else. So you can just have a switch statement or something in here to do what you want to do, handle it the way you want to do. And specifically, you would just override this function rather than changing the one in here. You can just override it in your actual grouped items page or whatever your main page is called. So that's fairly straightforward. So the trick here, obviously, with using grid view is you switch it for a list view, if that makes sense to you. Now, the minimum requirement is that you must support snapping. If what you're doing doesn't make sense to operate or continue operation in a snap view, you could simply just hide your grid view and show an image, which might just be the logo for your application. That's fine too. That should pass certification. It's not great for the end user, but some applications just don't make sense when snapped to the side, and hopefully the user takes the hint and goes, okay, yeah, fair enough, and snaps an application that makes sense, like Twitter or something else where there's information that's useful to them to have at the side. So pretty straightforward. Just follow this design example of setting things up. You'll also learn a bit about animation as you do it. So, pixel density. This is I think we're coming up to the last demo here. Pixel density, this idea that you might have this kind of resolution at 11.6 inches, or you might have a Surface Pro, a Microsoft Surface Pro, in which case you have super high definition. Now that's great, but the thing is everything gets smaller, or at least that's what would normally happen, is there'd be, you'd see more information, images would get smaller, all this kind of stuff, but that's not actually what happens. When the DPI goes up, the system actually does some work. Also, you have to be careful, but it has to do this work, otherwise things would get too small to touch. So if everything just got smaller because the dots per inch went up, then it would be a very unusable experience. So what actually happens is, you can see that, I'll just go flip back there. This is what would happen if nothing was done. Increased DPI, everything would get smaller and maybe untouchable or illegible. What the system does is, anything that's to do with XAML, it just scales it up to match. And if there's an image there, it will also scale up the image to match. So it maintains this kind of minimum ratio that you need. Obviously, with a higher DPI, you're going to get a nicer experience for graphics and all this kind of stuff. However, so that's what's happening. It scales up to match the density. Everything will look crisper and nicer. And there are 3 scale percentages that it might consider when it might scale up. It might scale up by 40% or to 140%, or it might scale to 180%. So for anything that's vector drawn, this is fine. It'll just look really good and really crisp because there'll be more dots for the same amount of graphic, and everything will look just great. However, it's not going to look great for images. What's going to happen is the layout, as I said, will get scaled up automatically, but we need to ensure that we get crisp rendering of images. If you're using HTML, you could use CSS or SVG to do some of this stuff, or with XAML, you can use paths to draw stuff. And for bitmaps, you can use a trick called resource loading. So as I say, the image is going to get scaled up, so the image is going to look potentially more blocky on a high DPI display, because it'll take the same physical area, but you didn't give it any more pixels. So what you need to do is have a way of having more pixels so that you can use those dots that are in the same inch. It's kind of hard to explain, but certainly if you think of it, this is how we're going to solve the problem. What we're going to do is, by default, you give the images that are used in your project, let's call those 100%. If the system detects high DPI, it's going to scale your image up, and it's going to go, okay, we'll just use what you've got. But if you want to have a high quality experience, either switch to vector-based graphics, using kind of XAML paths or similar, or shapes, or supply another image with a higher DPI, 140%, 180%. The big magic tip here is always have images that are a multiple of 5, because if you add on 40% or 80%, you'll still get a whole number. If you don't have a whole number, you're going to get potential artifacting. Now, what the trick is here, if I have an image called foo.jpg, if I supply files in my project that are named in this particular naming fashion, the system will automatically pick them up and use them when it detects the higher DPI. So one last demo here is, and of course it's hard to show without switching physical devices, but I'll do my best. So in this particular example, there are some images. Some of these are images and some of these are vector based. So you can see it's telling me what's going on with the screen. It's telling me what the DPI is, all this kind of stuff. Now, I'm just going to quit the application. If you want to test this without having a machine, you can use the simulator. So let's fire up the simulator. The simulator does a remote desktop into your own machine. Let's just see if it works nicely in this. I'm not sure whether it'll capture properly on the video, but we'll give it a go. So it's going to start the simulator. Again, it's just a remote desktop into the machine. It's just deploying it. Almost there. So this is actually really my machine being logged back into here. So here we go, and what you can see is we've got a certain resolution set. So let's just do this. Let's say first of all let's just change the setting here. Where we go? There we go. So this is 1366 by 768. Let's say we cranked it up to 1012 like this, and do the same trick, and then you see what happened is the system automatically scaled things up. Let's go and launch now the project for scaling and see what happens. Here we go, project for scaling. Whoops, need to launch it in the simulator. Set it as the default project, and go to simulator, and off we go. This is a great way of being able to test this without actually having to have 5,000 devices to test on. So you probably won't be able to see this, but you can start to tell what's going on. You can see it's automatically increased to 140%, and it knows what the DPI is. Now, because it's done that, it's going to pick up a different file. Let's go to Solution Explorer and have a look inside this project. You'll see that I have 3 different projector images. If I were to go and look at that one, if I go open with, let's say, Paint. Just going to open with the Paint. I'm just going to scribble on it like this, so we know it's a different one. I'm going to save it. I'm going to relaunch my application. And what you'll see is that, they're the ones that were loaded in automatically. That's drawn with XAML with vector graphics, but you can see that I've pulled in the 141. If let's just risk it, let's go back down to the other resolution right now, and see, and you'll see that this one has gone back to the 100 one instead. If you look at the code, you'll see exactly how that's done. But for free, you can get this image scaling and higher quality images on a higher definition device. Okay, so the built-in controls are designed for touch, mouse, and keyboard. If you design your own controls, you should certainly do the same thing. But you can see that it's good for it. It's certainly there. You should also learn the different interactions you can do with touch, because touch is quite a key component. You can you can programmatically do things with touch and capture gestures as well, such as rotation, and pinch and zoom, swiping and dragging, and various other things. So there are APIs that allow you to call out or handle gestures specifically. So also consider that with the controls that you use. Animations, we saw some very subtle ones for controls fading in. Consider using them, liberally, not too liberally, but judiciously, I should say, because they'll add to the experience. And you can build that into you can use the ones that are built into grid view or list view, or you can build some of these animations into your own controls as well. So you can do that. There's animation library available for HTML and JavaScript, and there are also some built-in transition animations available for XAML as well. If you look in the standard styles.xaml that was inside the project templates, the standard project templates, you'll see where it applies the specific animations that are used for kind of like new items being added to lists and when controls appear on the screen as well. So we've talked about using the built-in controls and what that does for you. We've explained, or you've seen demos of them in use, and some of the extra features like spell checking, touch, mouse, keyboard support, all that kind of great stuff. These controls also work well with different screen sizes. We've talked about layout and how important it is to handle that, and the different views that you might have to deal with as well. And again, we've designed for touch, mouse, and keyboard in your application. So there also, like I said, there's a way to pick out touch separately if you want to handle gestures. Add animations or use the built-in animations that are there for free. Your animation can look just great with some of the standard animations already there. These are some of the next steps. If you don't have Windows 8, definitely go and get it. You can get it for free. Pretty much every machine on the planet you can buy an upgrade for. You don't need to buy a full version. You can upgrade to it if you have a previous version of Windows. They're all eligible. Get started today by following these links, and also give feedback about this session, the content, whether it was presented well. Of course it was. In 45 minutes, there's a lot of material to get through. If you have any questions, feel free to ask questions on the live Q&A if available, or send me an email, or follow me on Twitter, Colonizer, so COLINIZER, or go to my blog at colonizer.com. I occasionally post things about ways to solve interesting problems on my blog, or you'll see me talk about news that comes up that's relevant to XAML and Windows 8 on Twitter. So thank you very much.